Assuming there's a backlog of energy or glucose in your bloodstream, what will happen? Because your body doesn't like too much glucose in your blood for too long, and they doesn't want to waste energy, because this calorie is very precious, food is very precious. This is a natural instinct of your body. So they said they want to conserve the energy. Where does it send to? So they will go through another pathway. If you're not burning through the cell, then they will store it, use the liver. Hello everyone, today's topic is about how the body processes calories. If you want to lose weight or you want to better manage your glucose or your blood glucose problem or diabetes problem, you need to understand how the body processes calories or the energy in the form of food. And for this, you need to understand the metabolic pathway. So this is the diagram. Don't get by this. I will try to simplify it step by step. Then you will get the understand clear picture of this big picture. You need to understand big picture. But for understand big picture, we go step by step. So first step, the food you eat, the one you dread. The modern people so worried about your rice, your bread, your noodle because of the high carbs, high calories can cause high blood sugar and then fat. So this is what people concerned about. Actually, they are in nonsense. We need this. You grew up with that, right? I grew up with this. I'm still living on this. But people scared because there's something wrong in the pathway. So to understand what goes wrong, we have to understand what is normal pathway. What happened to this food? How does it convert to energy and then disappear from your body? So the food go into your tummy and then it get digested with the help of enzymes. Thanks to the enzymes. So glucose enters the bloodstream. So glucose goes to the bloodstream to deliver to the place that it needed. For example, now I'm speaking in the high speed. My brain is paining, my mouth is moving, all this muscle I'm moving. So these muscles require energy. And the fastest form of energy is glucose. Your body prefer. But of course, it can use fat. I will talk about fat later. So for example, now my brain or my muscle need the glucose. So the glucose will be sent to the cell. This is what happened inside your cell. What happened when glucose enter the cell? And the entering of glucose into the cell require insulin to assist to open up the glucose channel. Today we are not talking about that. So assuming your insulin function is normal, your receptor is going fine, so glucose successfully go into the bloodstream, your cell, not bloodstream, from bloodstream into your cell. What happens? Glucose will go through the first step, glycolysis, where the glucose will be breaking down to half. Glucose consists of 6 carbon. So the first step of glycolysis, first step is an anaerobic. It doesn't require oxygen. It will break down and then produce pyruvate, or another name for pyruvate is your lactic acid. And this process, they generate 2 units of ATP. So, and then the byproduct or the halfway product of pyruvate goes into the Krebs cycle with the help of oxygen. Without oxygen, Krebs cycle is not functioning. They are not opening, and then the pyruvate cannot go inside. It will get expelled out from the cell, become in the form of lactic acid. So in order to completely burn your glucose, you need this Krebs cycle to open. And what is the key? Oxygen. So oxygen delivery is very important. That's why aerobic exercise is good for burning glucose and burning fat. So Krebs cycle open, the pyruvate go into it, and then it will completely be broken down into carbon dioxide and water. At the same time, it produces high amount of ATP, around 36 units, compared to the first layer, only 2 units of ATP. But if completely burned through the Krebs cycle, 1 unit of glucose will produce 36 units of ATPs. So to maximum burn and completely get rid of the glucose or energy is have to go through the Krebs cycle, and then the byproduct is carbon dioxide and water. You spit it out. So the energy won't store inside. Assuming if the Krebs cycle is not working well, due to insufficient supply of oxygen, pyruvate will go into the bloodstream in the form of lactic acid, I mentioned, right? Lactic acid will be sent to the liver and then combined back to form glucose again. So glucose will be looped around and around. That's why we don't want anaerobic exercise and respiration too much. We want aerobic metabolism. This is aerobic. So you need the Krebs cycle or the mitochondria. This thing is called mitochondria. Did I mention just now? Okay, mitochondria to work efficiently. So, and then of course, with the demand, you need to work. You need to have the demand. It means like now my brain is like calling for energy. That's why this whole mechanism will be activated. If I'm lying there doing nothing, not activating my brain, not learning things, not involving active thinking, and not moving at all. So, and I like to eat, then there will be excess of energy backlog. So what happened to this excess of energy? So let's go back. Will backlog start in the bloodstream because there's no demand on cell, right? So no point sending the glucose into the cell. So of course, to lose weight, you need to engage cell activities, either physical activities or mental activity or some other activity at night. Or daytime. Okay, don't go too far. Okay, assuming there's a backlog of energy or glucose in your bloodstream, what will happen? Because your body doesn't like too much glucose in your blood for too long, and they doesn't want to waste energy. Because this calorie is very precious, food is very precious. This is a natural instinct of your body. So they said they want to conserve the energy. Where does it send to? So they will go through another pathway. If you're not burning through the cell, then they will store it, use the liver. So the liver will absorb all the excess glucose and then to form glycogen. This is how your body, the liver store your glucose. So our external source of glucose is from starch. Starch is actually a binding, as a link of glucose. So after digest, it get broken down. Now you have too much glucose and the liver will connect back and join back, but it's not called starch inside the body. Inside the body, it's not called starch or carbo. Inside the body, it's called glycogen. That's why if you eat pork liver, you find a bit texture, the Chinese call fan fan. I don't know how to speak in English. Anyway, but there's a limitation of glycogen storage in the liver. So when it's too much of the glycogen storage is full, but there's still a lot of excess glucose in your bloodstream, your liver will activate a second layer of storage, which means it will convert this glucose into fat and store outside the liver. The liver job is to convert glucose to fat and then store outside across your body, your double chin, your tummy, your fat on your buttock. A woman hates that. Okay, so this is how your body store it, and this process with it requires insulin as a stimulate. So far the process I mentioned, the elevation of glucose stimulate insulin. So talk about insulin, you have to mention about pancreas. Today is not only about insulin, it's about the whole energy mechanism. So, and this process, one of the key organ is pancreas, because pancreas manage your glucose level. When just now I mentioned is glucose elevated because you eat carbo, right? So when elevated glucose, your pancreas will release insulin under the beta cell. So it promotes glucose uptake by cell. So this insulin shout to the cell, hey, hey, cell, you all they have too much supply. You all activate a bit and store a bit or burn the glucose. So it's under the stimulation of insulin. So, and then it also promotes storage. If the cell are lazy and say, boss, I don't want to take your glucose, you go send it out elsewhere. So your body no choice, but it's still with the help of insulin, it order the liver to store, like what I mentioned just now. So it inhibits glucose production by liver, because your liver can store glucose and it can also produce glucose. When does it produce? When you are fasting. That's why when you're fasting, your pancreas release another opposite group of hormone. It's called glucagon. The objective is to raise blood sugar, because when you are fasting, your blood sugar level will drop eventually, right? Slow to below 4. But if you drop further, then you will KO lah. So your body have a detection system. It say, oh, blood sugar is low. So it will order your pancreas will detect it and will release glucagon. It will stimulate the glucose production by the liver, because just now your liver has a storage function. So this glucagon will call the liver, hey liver, come on, release some of your glycogen in the form of glucose. So your liver said, yes sir. Then we'll start to chop off the glucose and then release into. This is how your body maintain the blood glucose level. And also promote glycogen breakdown, like I mentioned, and release glucose into the bloodstream. It also promotes the breaking down of your fat. So in scientific term, it's called catabolic. Insulin is anabolic forming. So glucagon is catabolic breaking down. Okay. So now let's take a look. If in the event you don't eat carbo, Now very popular ketogenic diet, right? They eat fat from animal fat or avocado or drink oil, olive oil, palm oil, whatever oil lah. So they use oil as a main source instead of carbo for certain reason, for diabetes person, because the insulin pathway or the glucose pathway, which I mentioned just now, there are some problem with it. There are multiple issues, multiple factors, maybe in other video I'll talk about. So if that pathway has problem, the pathway I mentioned, the glucose pathway has problem, so they encourage people to supplement fat or oil as an alternative source. So if your body use fat as a source of energy, the same thing have to be broken down to fatty acid, because fat, it doesn't dissolve in water. Our blood is watery. It's a H2O. It's a hydrophilic. Fat is hydrophobic. Doesn't like water. So in order for the fat to travel in your bloodstream, it has to be converted to fatty acid. That's why you often heard the word fatty acid or triglyceride acids. So all these acids will eventually go into the cell, but it can skip the glycolysis process. Just now when I mentioned glucose go into the cell, it has to go through a glycolysis, produce pyruvate or lactic acid, then this will go into the Krebs cycle. But for fatty acid, it can straight away go to the Krebs cycle and produce a lot of ATP, a lot, 100 over. 1 unit of fatty acid can produce, if I'm not mistaken, 130 or 150 something, I don't forget. But just now I mentioned, one glucose can only produce 36, but fat can produce a lot of ATP. Then your cell will be, whoa, a lot of energy. But again, your cell need to burn it. If your cell is not active, you are not being active, your cell don't need all this ATP, then this cycle stop, and then there will be a backlog of energy in the form of fat. Now you understand? So now here's an analogy. So ATP power all essential body function. So now you understand. If you look at the very deep science matter, is your cells, every organ cells or function, the function require ATP. How to produce ATP? You can either go through glucose or either through fat. But through the mechanism, what? The main engine is what? Your mitochondria, the Krebs cycle. Not Krebs cycle. So very important. Mitochondria, now a lot of research is around mitochondria. Your aging process, your cancer is all related to mitochondria. It's very interesting topic. I will share more in the future. But anyway, you look at this. So mitochondria is like a genset. The food you eat is like the fuel, your petrol lah. And then the cell function, the function is like your electrical appliances. The cell can only use ATP. Just like your electrical appliances, they can only use electric current. But your source of energy is what? Petrol. So you need to go through a transformer to transform the energy from the chemical form into electrical form. So who is the transformer? In real life, it's called genset. But in your cell, it's called mitochondria. So your muscle, all these functions require a very efficient mitochondria to convert all this chemical energy into electrical energy or the ATP. Actually, it's really electrical energy. The ATP is our charges, a holder of charges, maybe on that topic and maybe later on. So if you find the problem that your glucose is very hard to manage, or you're always lethargy, very tired, and then your fat is like not burning at all, despite you going through all the diet program, excessive exercise, but it still doesn't lose weight effectively, then you should question, maybe your genset in your body or your mitochondria have problem. So analogy summary, just I mentioned, food is your fuel, and then your cell is like your power plant. The mitochondria is your power plant, and your body can use the ATP, like in electrical appliances, your washing machine, your TV, you can use electricity. So you use this analogy to understand. Then you have a better idea how to manage the energy, the food, your intake, how does it burn. Then you have to track down in which part in your body it goes wrong. Is this a cellular problem, or is it not enough oxygen, or is it because of hormone issue, or your pancreas is not functioning well, or your cell, the receptor to the insulin is not sensitive enough, or then that's why it's losing weight is not as simple as exercise more, eat less. No, it's very much complicated. But I try to make it not so complicated. But first, you need to understand the metabolic pathway. Okay, that's all the sharing for today. This is now everything seems simple, right? All right, thank you. But it is a preview. What next? Up next, I will talk about how the body processes energy during fasting state. That means when you are not eating, what your body does. How does it use the internal fuel? Your internal fat law. So this is important. But prior to that, you need to have this basic understanding. But you give me some time because I need time to work about the slide. Work on the slide. All right. Bye bye.